Hey, QED Coders, this is Michael. I'm the Director of Consulting at Improving in the Dallas office and maintainer of the Jinaga open source framework and author of The Art of Immutable Architecture. And somehow all of these things are related. I would like your help with something. I have put together this project called GameHub. And the idea is that you can build your own game using GameHub, and in doing so, it will teach you how to construct a full Jinaga architecture. It is a pre-packaged architecture with an example game built into it, and so you can pull it, you can change the code, you can modify the game a little bit, modify the game a lot, or even make it something that's not a game. The choice, of course, is up to you. I would encourage you to start with the simplest change. Just let's take the game that's already there and make a slightly different one. So, what I would like you to do, if you could, very much, please help me with this experiment. I would love you to fork the repo. The link is in the description. And then to clone that into your own working directory, and then make your own game. So steps 1 and 2 are pretty simple. Step 3, a little bit more involved, but I think you can manage it. Every step along the way, I want you to respond in some way. Let me know what your progress is, how you are experiencing Jinaga, how you're experiencing GameHub. So ways that you can get in touch with me. Get in touch with me on just by leaving a comment right here on YouTube. Go to immutablearchitecture.com and join the Discord. Get in touch with me there, or email at michael@qedcode.com. Any one of those, I would love to hear every step of the way. So I have forked the repository, and here's the link. I've cloned it. I've built it. I've played a game. I've modified it. So I want to hear everything that happens, so that we can learn together what is going to be a useful addition to how we document and package up Jinaga. So let's talk about where to get started. So right here, again, the link is also in the description, is the repository. So github.com/michaellperry/gamehub.com. That's where I want you to go, and then fork this repo. All of these instructions are right here in the README, including a helpful little diagram showing you everything that's included. Then it even goes through the architecture and the technology and how to build your own game. So I've got it right here inside of Cursor. This is also optimized for use with Cursor. If you're using Windsurf, import those rules from Cursor into Windsurf. That really helps out. And then right here, we've got the README. What is GameHub? Let's get started in just 10 minutes. So you fork it, you clone it, npm install, npm run build model, and then npm run dev player. That starts the player interface. What is the player interface? Well, here we are, npm run. Well, let's first of all build model just to be sure that we've got, oh my goodness. Oh yeah, I need to change to the app folder. Now I can npm run build model. There we are. That builds the Jinaga model, so that now I can use that inside of the player interface, dev player. So the dev says I'm loading it up in dev mode. It's not running within the full architecture. It is just running in developer mode. And that's what we get. We have 2 tabs now. So here is the GameHub lobby. From here, you can see we've got some simulated players. We will talk about them in a little bit. We can start a new playground. We can join a playground by entering a 6-letter code. And we don't have any playgrounds yet, so let's go ahead and start one. Boom, I've started a playground. There's Leroy Jenkins, that's me. Oh, Mugman has just joined. Oh, Mugman has just issued a challenge. Mugman is a simulated player. Let me go ahead and respond to that challenge. So he wants to play a game, accept to start playing or reject to decline the challenge. And the first move goes to Mugman. So, alright, he wants to go first. Let's go ahead and accept. Now we've got Mugman versus Leroy Jenkins. And you see Mugman has already made his move. Simulated player. Okay, let's go ahead and go here. And he's going to go there. He's not a smart player. And I will go ahead and win. Hey, I won the game. Woohoo! If I go back to the playground, you can see I still have the game there. Of course, the game is done, so I can't click any of the squares. But you know what? It's time to end this game, so let's return to the playground after ending the game, and now the game is gone. From here, of course, I can challenge Mugman. I say, I want to go first this time. So I start, I send the challenge, and then simulated player will accept the challenge. So here's Leroy Jenkins versus Mugman. And now I get to start. Haha. And then he's going to respond. You know, I'm going to grab that center square. Haha. Let's come on, you can do it. I believe in you. Hey, he won. Oh no, better luck next time. Okay. So, that is GameHub. And of course, right now, the only game that it has is Tic-Tac-Toe. But your challenge, should you choose to accept it, is to fork this repo, clone it down to your machine, get this built and running, see all this working, and then build your own game. See what you can do. To help you along your way, what I want to do today is to walk through the Tic-Tac-Toe game and show you how that works. What are all the pieces, so that when you want to make your own game, you know exactly where to go. So, let's kick things off by taking a look at the project. So we've got our documentation over here that kind of shows you everything that's happening. Well, the architecture diagram is not showing up inside of the README. Well, let's go back here and take a look at it here. Okay, architecture diagram. Within this repository, we have a lot of components. We've got 3 front-end components. There's actually, this is out of date. It doesn't have the player interface. It's got 4 front-end components. The player interface should be up here as well. As the admin, setup wizard, setup dashboard. It's all running through Nginx. And then back here, we've got some back-end services, including the Jinaga replicator, which you can see a lot of things depend upon, because that's the way that they all interact, that they all provide their services and play within the same playground. So there's the Jinaga replicator back there, and we've got a few internal services only, like a service provider, so that these things can all authenticate with the Jinaga replicator. So for the purpose of building your own game today, we are only going to be focusing on the one box that's not on this architecture diagram, the player interface. So within the player interface, so that we'll see inside of the app folder. We've got a few projects in here. Only 3 of them are listed so far on the README, but the GameHub player is one of them. So under app, here's GameHub player. This is a monorepo, so all of these projects can depend upon one another. The GameHub player depends upon GameHub model. And inside of the model, we've got several different types. These types all represent facts. Like here is the type that represents a game. Here we've got a challenge. And down here we've got a move. A move happens within a game, and it has a certain index. In the case of tic-tac-toe, it'll be 0 through 8, and a position. Tic-tac-toe also 0 through 8. And so this fact represents that somebody made the decision, somebody made a move. So we record that decision as a fact. And you can see this move references the game. I made this move in this game. So if I go back up to game, I'll see, what does the game do? Well, the game references the challenge. I started this game in response to this challenge. Oh, what about the challenge? Let's go back up there. That says that the challenger joined, the opponent joined, and then I issued a challenge. Either I want to start or I'll let them start, and it was created at a certain time. So you fill out this dialog, you push send challenge, and it creates one of these. So this is how you build up that history. Each one of these is pointing back in time. Like we're pointing back in time to the join. A join means that a player joined a playground at a certain time. What is a player? A player is a here's a player. A player is a user on a tenant, and it just keeps on going up and up and up. Actually, these are really close to the top now. User is a top level. Tenant is almost top level. Tenant was created by a user. So we get all the way up to the top. This is where history begins. And then as things progress, you create more and more facts down the chain. If you want to see that chain, we can go to the docs folder. Docs, boom. We want models. Here is the playground document right here. So let's take a preview of, let's see if we can do a graph as preview. There it is, of the model. So we talked about moves within a game. A game is in response to a challenge. A challenge is two players, or two instances of join. There's an important distinction here. Why is it not player? Joined is a player joining a playground, and a playground is something that happens inside of a tenant. So if we start from the top down, we can kind of trace the history of what happens in the application. So let's go back here and go all the way back to home. You can see I've got a playground right here already. So when I'm here, I am already inside of a tenant that was set up at the beginning. So that's one of those like deployment tasks. Then when I logged in, which happened kind of invisibly in this particular application, then it created a user and a player in that tenant. So now I'm logged in, and as I'm logged in, I can see your playgrounds. What playgrounds have you joined? Well, I'm starting as a player. Let me look for which joins exist, and then that gives me all the playgrounds, and now I can display their codes. So just run that little query, and I get that thing. Or I can create a new playground fact and then join it. And that happens, both of those tasks, both of those facts occur when I hit the Start Playground button. So now I've got both the playground and the join, and it's got a brand new code. So now somebody issues a challenge, like Zelda has issued a challenge. So if I were to issue a challenge to Zelda, I get to choose, does Zelda start or do I start? So I can set the challenger starts boolean for this brand new challenge fact. The challenger is me, the opponent is Zelda, and it was created now, or it's created now. As soon as you push that button, that's what creates the challenge fact. Then Zelda gets to reject the challenge or create a brand new game. So those are the two responses that are valid for a challenge. if I take a look here, I've got my incoming challenges. These are the challenges made to me, so I know that I joined this playground, and here's my join fact. And so if I am the opponent in any of these challenges, then that is, that shows up here. And now I can respond. I can create a game fact, or I can create a reject fact. So I'll create a reject fact, and boom, that challenge disappears because I'm only looking for the challenges to me that do not have one of these two, either a reject or a game. And then meanwhile, Zelda has accepted my challenge, so there is another game fact over here for the challenge from Zelda, from me. Anyway, one of those two. And so now it's my turn. I make a move, and that creates a move fact. Now when we are all finished with the game, and one of us wins, or one of us draws, or both of us draw. Okay, so Zelda has won. So that means we just created a win fact, or we're about to, once I hit this button, end game, we're about to create a win fact where we declare Zelda, the player, as the winner. If I don't create that fact, then this game still appears because I'm looking for all of the games in this playground. So all the games in this playground where there does not exist a win or a draw. But once I push this button, I created the win fact, and now that game no longer appears in the list. That is how the Jinaga model works. You query things based on the graph. You display the lists of your results. Those are called projections. And then you make decisions and record new facts. That's all there is to it. So let's talk about, let's go back to, if we go back to, boom, 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 this here, gamehub.ts. We talked about the different facts that occur within this model. What we have not yet talked about is all of these static functions that are attached to these facts. So let's look at this. I am looking for the moves in a game. So I've got this label of type game. So I don't know which game it is. It's just a label coming in right now. I can't actually access any fields of that game. But what I can do is I can look for successors of type move. So I'm looking for the moves in this game. And how do I know that the move is in this game? Well, if I were to start at that move, I could look at, hey, point up, that's the game. So that is how we say, I want the moves in this game. If I find where that is referenced, I can see that is, oops, okay, go to references. It's not finding the references. Well, let's get my little buddy over here to help me. So, hey, I'm going to ask, where is the move.in static method used? And so it's just doing a grep. Use player session, use game. Use game. Actually, that is where it should be. Okay, use player session, use game. Yeah, use game is the one that I'm interested in. Let's go here. Boom. So here is use game. I am looking for right here, move.in. This is a specification. So given a game, I want to match all the moves in that game. And once I do, I want to select the move ID, the index, the position, and the move fact itself. So that object right there with those 4 properties, move ID, index, position, and move, that is a projection of a move. And so this specification, starting with the game, will give me an array of those projections. However, with this, I'll see that this is a specification of that projection type. Well, let's see how this is used. This is down here. I have use specification. So use specification starting from this move, or starting from this game right here. That's the starting point. Now I want you to run that specification and give me back these moves projections. Yeah, a little double plural there. But yeah, you can see this is coming back as an array of those projection objects. Or no. Of course, things take time to load, so in React, we return null until it is loaded, and then we have that array ready for you. So that's how you use a specification in order to walk the graph and figure out what's happening. Now, this little guy knows Jinaga. How does it know Jinaga? It knows Jinaga because in here I've got some rules. So cursor rules, here's a bunch of rules. Some of those are Jinaga rules. So it knows how to create Jinaga facts. It knows how to create Jinaga specifications. And so this is why it's really valuable to use Cursor or Windsurf or GitHub Copilot in order to work with this repository. As you can see, I already have it set up for Cursor, so it's optimized there. You can import those rules into Windsurf with a single click. I don't know if that is here or coming soon for GitHub Copilot, but yeah, you should be able to reproduce this same basic idea in any AI editor that you're using. So let's do that. Let's ask. I am really curious about moves spec. Boom. Let's come back up here. Explain how moves spec works. I think I might have to say to include the static method. Right now I'll leave that out just to see what it does. So it examines the code. Now let me look at how it's actually used in useGame. Oh, it's looking at use specification. Okay. It's a Jinaga specification. It specifies how to query and transform, not transform, just query, move data for a specific game. Well, I guess transform as in project, but not mutate. So, breaking it down, start with a game fact as input. Find all move facts that belong to that game. And it's just talking about move.in. And then transform each, so transform to it means project. Okay, so it does look at the move.in game method, and here it sees that this creates a query that finds all move facts where move game property equals the given game. Perfect. And then it does the data transformation. Usage in the hook. What happens? The use specification is a React hook from Jinaga React that specifies real-time data. So it takes the move spec and it returns an array. It returns an object with the array of transforms. And real-time updates. Here is the important part. It subscribes to the Jinaga replicator for real-time updates. Okay. This is reaching into those rules, and it understands how Jinaga plays within the architecture. It re-renders the component whenever new moves are added to the game. Perfect. And it maintains that subscription until the component unmounts. So, that is how, when I'm over here and I make a move, go ahead, Zelda, you make your move. So when Zelda made the move, I saw it because I'm subscribed to that specification. All the Zelda did was created a move fact, and then use specification updated it. So I make my move. All I did when I click there is I created a move fact. I didn't set state. I didn't send a what is that? Yeah, use yeah, the redux, the flux thing, a reducer. I didn't use reducer or anything like that. I didn't send an action. That's the word. Instead, I just created a move fact. Let me show you that code. So we are here inside of the, let's see what we're inside of. We are inside of useGame, and if I take a look here, you know what? Let's ask our friend over here. Where? I just realized it's hard to see what I'm typing underneath my picture, but I'll just read out what I'm typing. So where is the move fact created? Or if you didn't know that all we're doing is creating a move fact, you might ask, what happens when a user makes a move? Go ahead and ask those questions. See what it comes up with. So it's created here in use game on line 190. Does that take you to the line? No, that just takes you to the file. So 190. Boom, boom, boom. So create the move fact. Oh, nice. It didn't take you to the constructor call. It took you to the comment. Like, this is what we're doing. It's a language model. It's not a code model. So create the move fact. So that's all we're doing. Once we have that move fact, we return. We're done. So that's all that you need to do whenever somebody makes a decision. You can see that there's another one inside of use player session. Let's go there real quick. And in here on line 337, 337, we are inside of this final function here, make simulated move. So this is the player simulator. And we're going to wait for a random delay, find all the valid moves inside of the game state, pick one at random, and create a move fact. Then we're done. We have simulated the player doing a thing. And so that triggers the use specification to update and return that new move inside of the array. So that causes a re-render and the move is displayed on the screen. So whether it's the user doing it or another user doing it, no matter what, the use specification subscribes to any new facts that would change how that projection results. Okay, so that is how we are making moves. So let's talk about what it would take for you to create your own game. To do that, let's return to the model. Here's the preview of the model. Okay, we are down here. We're talking about challenging. We're talking about games. We're talking about moves. Let's take a look at what this model implies. The challenge, as you can see, has the challenger and the opponent join. So that implies a two-player game. Challenger starts, Boolean true or false. That implies a turn-based game. And then the game has moves. Each move has an index, which again implies turn-based, and then a position. So this implies that the game somehow you make a move by selecting from among some set. And then you put those moves in order, figure out what that means in terms of the game, and then you can display that to the user. So, easy mode for build your own game, which I recommend you do for the first time. Pick a game that fits this this shape. For example, you might choose Connect 4. So you have 7 positions that you could choose from, 0 through 6, and it's which of the columns do you want to put your checker in, and then you try to connect 4. Some other options. Chess. Chess is a 2-player game, turn-based. The position is a little bit interesting. With chess, you move a piece to a position. So you could hack it and squish those two pieces of information into one number. Multiply one of them by 64 and add the second one. Shove them into the same number. That'd be kind of weird. So if you want to make chess or checkers or Go, well, Go actually fits this move because you just place a stone. And then you resolve your place by removing other stones. But that's part of the board logic. All that you did as a player is you decided which position to place the stone. So Go actually fits this one. But if you wanted to do chess or checkers or any of those move as in pick a piece up and put it down somewhere else, then you would want to modify this right here. So rather than position, you would have from and to, something like that. So I still consider that easy mode. You're making a change to the model, but that change just involves changing the fields. It doesn't involve changing the structure, how these facts are related. So that's easy mode. Slightly harder mode is then if you wanted to add a little bit of extra information to the game. One idea there is to do something like Battleship. So of course that's a trademark, just like Connect 4 is. So come up with a different name. But with Battleship, it's not just that you take turns making moves. It's also that you would deploy your fleet. And so after the game starts, you have some phase in which you are deploying the fleet to the board. You lock that in, and then you can start making moves. So that would be a slight change to the model. Let's talk about what that change might look like if one were to do that. So we'll go to the playground dot. And so here, after we've got a game, but before we make moves, we might want to have a fleet position. And this is for a game. And maybe it's for a particular player. So let's take a look at that. What would that look like? So, wait a minute. Why aren't you updating? You toggle open preview to the side. That'll be good. Here is, yeah. Let's reverse these positions. Yeah, let's see. You go over there. I'll figure out this interface one of these days. Okay, you go over there. And now, scroll. Here is the fleet position. So within a game, you will position your fleet for a particular player. So it's either going to be the opponent join or the challenger join. One of these two is going to have their fleet position. So let's talk about the fields that are in the fleet position. So we might do something like we want to know the ships. Let's write this out this weird way right here. So this ship, we will do like a number, or we'll do a string. So it's going to be the name of the ship. And then we will have its position and its orientation. There we go. So we're keeping track of the ship, the position, the orientation, and so maybe we have an array of those things. So we just record that all as one fact. So I'm imagining you're moving your fleet around. You're saying, no, that's not quite right. Let me move this one. Let me rotate it. And then you say, okay, that's the way I want it. You push a button that locks it in. Only then does it create this fact. One and only fact. Not individual facts for moving things around. That's kind of what I'm envisioning. Unfortunately, I've got this little array symbol right here because we have multiple ships in our fleet. So the unfortunate part is that in Jinaga, an array is treated as predecessors. So you can have an array of predecessor facts, but you cannot have an array of just regular values. So yeah, instead Jinaga would see this as if these were facts and not values. So probably a good way to do that is basically stringify that whole structure, and we'll have a position string is our actual field inside of that fact. So that position string records the position of all of the ships in your fleet and their orientations. Okay, so you would do that, and then and then both players would have to do this before you started making moves. Now, that could just be game logic. That could be, let me take a look at the game. Let me take a look at the fleet positions. Do I have exactly 2 fleet positions? Okay, now I can start making moves. Or you can encode that into the model itself if you wanted to do something like that. So one way that you can encode that into the model is to change the predecessor relationship here. So you can't make a move until you have 2 fleet positions. Let's record that as part of the model. So having 2 fleet positions, we will call that a game begin. So what does that mean? That means I've got a fleet position, which I will label as the Challenger fleet. That's good. And then we will have another fleet position that we call the opponent's fleet. And it's trying to do a whole bunch of predictions. Let's see what... oh, I lost my... Yeah, there we go. I lost my fleet position. Fleet position... Nope. Fleet position refers back to game. Alright, there we go. That's what I wanted to draw. Okay, so yeah, so a game has been created. You've challenged somebody, they've accepted, there is a game. And now you create a fleet position for that game, and for yourself as a player. So there's that player. Okay, game, fleet position, capture your position as a string. This is my position within this game I have declared. And so now once you've got a challenger fleet position and an opponent fleet position, now you can create the game begin fact. The game begin fact does not need any other information. That's what I was trying to delete. It's just simply game begin. Can't really see it right now, but that'll change in a little bit. And so now move relies upon game begin with a capital B. There we go. So you can't make a move until you begin a game. You can't begin a game until you have 2 fleet positions. So we've basically recorded that part of the game logic into the historical model. And so we make that part of the model, and now that is enforced not just by your game logic, but also by the Jinaga model. Enforced by the replicator. You can even have this be controlled by the authorization rules. Who is authorized to create this fleet position? Well, only the player. Yeah, only that player's user is authorized to create that fleet position. Then the other one has to be the other player. And then before you create the game begin, make sure that both of the players are represented here by the challenger and the opponent joins. And that goes back to the player user as well. Make sure that they are both have their fleet positions. One advantage of making this part of the model is now you know for sure when you make a move, this move is predicated on these particular fleet positions. So you happen to know that, and if somebody were to try to create a new fleet position, then that would not be part of this game begin. Game begin points up to those predecessors and locks them in. And so if somebody created another fleet position, it'd be out over here. This move would not be related to that fleet position. It'd be related to this one. So making this part of the model really helps out. So that's one of the reasons that you might want to change the model. This one changes the model a little bit, actually, somewhat significantly. I think that's a pretty big change. And if you wanted to go even bigger, then you could create a game that is not a two-player turn-based game. Maybe you want a multiplayer turn-based game. Maybe you want to do something like Bug House. So you've got 4 players. They're each taking turns, but they are not taking turns relative to one another. You don't have to go 1, 2, 3, 4, 1, 2, 3, 4. You might want to do a card game. You've got multiple players, but you all take turns. Interesting thing about cards is that you've got hidden information. Actually, in this game, you've got hidden information. If you had access to this model, and in fact you do, then you could see the other player's fleet position. That might be a problem. How do we handle hidden information? We'll get into that a little bit in a future episode. But you can decide how far you want to stray from the 2-player turn-based tic-tac-toe style game, and see how far you want to go. So, what's the other thing that's necessary to create your own game? We talked a lot about the Jinaga model. There's also another part. So let's go back to go ahead and save. I will use that updated model and build out the Fleet Duel game. Remember, it can't be Battleship. It's got to be Fleet Duel. So inside of Game Hub Player, you've got lots and lots of hooks, all sorts of hooks. My goodness, hooks for days. And so some of these hooks, like use game, are very specific to tic-tac-toe. In fact, use game, if I take a look here, here's my actual use game hook. You can see it's got lots of little helper functions that it calls, like compute game result, compute player role, all that stuff. Where does that all come from? Well, let me show you. You have the specification that we just looked at here, that is using the moves spec in order to get back a moves projections. And so now, as long as you have the moves projections, then you will compute the tic-tac-toe state. So let's go in there, compute that tic-tac-toe state. We've got a list of moves, and we know who the challenger is, who the opponent is, and so we play tic-tac-toe. You might be familiar with this pattern right here. This pattern has a very fancy name. We're going through the list of moves, and for each one we are updating the board position. By the time we're done, we have a board that's all filled out with all of the moves that were played throughout history. You recognize that pattern? That's event sourcing. That's all it is. It's a loop. It's a loop and mutate a thing. Event sourcing. Demystified. So here we event source over the moves, and we produce the board position. Now we go on to evaluate that board position to see what it means. So, do we have a winner? Let's look for all of the lines. So is the game over? It's over if we have a winner or every cell is full. Who is that winner? Is that the challenge player or the opponent player? So this is the game logic that actually represents tic-tac-toe. It turns that array of nondescript move objects into an actual tic-tac-toe board. So to build your own game, you would want to modify this. And this, again, is where our little friend comes into play. So let's go back to cursor here. We want to clear out this this context, and let's just let's start. Let's do connect for, because that fits within the tic-tac-toe or the two-player turn-based move type of game perfectly. So let's do that one. So I'm going to start by create a PRD for the connect for game. Completely describe the gameplay and rules. So you can do this inside a cursor, you can do this outside, you can do this in ChatGPT, whatever you want to use. I typically use ChatGPT for all my PRDs. It goes into the canvas mode and it writes out the PRD, and then I say nope, not quite. But yeah, here it's creating the connect for PRD, and because I told it exactly how this documentation structure is organized, it created that in the docs PRDs folder. That's where I like to keep my PRDs. So we come over here and we will see, collapse that all down. Here's our docs folder, PRDs. Here is our playground. Here's our player session so that we can simulate players. The tic-tac-toe PRD, I thought that was in there still, but apparently I was done with that. Here's the connect for PRD. Boom, let's keep it. And so we can read through and say, yep, that's actually tic-tac-toe. Always review the output. Now, let's do a quick scan. Anything here? We've got this visual design, 3D appearance with shadows. That's kind of cool. The board representation, red or yellow. Game state interface. It's actually seeing a bit of the implementation of tic-tac-toe and saying, hey, let's do something similar to that. So we've got, I was thinking I was going to rip this part out because it's getting into implementation details, but it kind of got those implementation details right, so we'll leave that in. Product requirement documents tend not to have implementation details, and in fact I told it not to do that, but it did it anyway. I say avoid putting code inside of PRDs and plans. So we've got all of those things. We've got some non-functional requirements. Yeah. Those aren't bad. Okay, we'll keep those. And success criteria, and future enhancements. AI opponent. Okay, yeah, we'll do one of those eventually. Custom themes, sound effects. Nah, we're not going to do any of that. Let's rip those things out. Boom, 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 boom. Spectator chat. Nah. Ability to review played games. That's kind of cool. We might actually do something like that. So statistics, tournament mode. Yeah, let's go ahead and keep those in the future enhancements. So now we've got a PRD. Let's create a plan. And I always like to start a brand new chat. And then let's create a plan. Now, it's already, that was a really bad prompt, I understand, but it's already got rules that tell it what I mean when I say plan. So, what I mean when I say plan is to put something in docs plans, use checklists, do not put code in there. So it really wants to code. So okay, here's the name of some functions, and so it's coming up with a plan. Okay, and of course, when it's done with the plan, we want to completely review the plan. Don't just spend 2 minutes like I did with the PRD. Actually go through it and imagine, okay, if it actually did this part first, would it be successful in the second part? If anything is off in the plan, do not proceed with that plan. You have to keep these things on the rails. Okay, so now we have a plan. I will hit keep so that we can read this. And in fact, I'm going to make this a little bit easier on myself, and I'm going to preview this with Markdown. There we go. Markdown preview. Okay, so we've got our phased plan. We want to make sure that we've got the tic-tac-toe game running, all that stuff. So we set up the domain model. Then it says go to authorization rules. I specifically told it to hold off on authorization rules until later. It really wants to do authorization rules next. So I'm coming in here. I'm saying authorization rules. Actually, I'm going to prompt it. I'm going to say move the authorization and distribution rules to a later stage phase. Implement security rules. Those two are security rules, authorization and distribution. After creating tests. Okay, so that should move those to a later phase. Gotta get the plan right so that we know that we are going to be successful. Okay, so moving those down. Let's go ahead and still working on moving them. Still working over here. Yeah, gotta renumber everything now that I moved everything around. Wait a minute, why is it checking things off? None of these things are done yet. Let's see, that's in progress, that's in progress. Where was that green check that I saw? Alright, well, let's take another look here at the preview. Alright, sit back, read through. Now we've got our information architecture. It added more to the plan. Is that... Wait, no, I'm looking at the PRD. Okay. Right, here's the preview for the plan. Okay. So, define the model. We've got our connect for game fact type. Okay, so it decided that it wanted connect for game, connect for move. Not a bad choice, actually. Using the generic term game implies that that fact could be used for any kind of game. But as we've seen, a lot of the game logic is encoded within the model. So we can't do that. And then we will have connect for TS. So we will separate our connect for TypeScript versions of the models. That's good. Core specifications. So I actually do prefer to write specifications as I need them, not right up front. You don't really know if you're going to have them up front. So I would again reprompt it, say move the specifications down later. Although maybe here, basic testing, no, I would still say test driven. Write the test first, and then we can figure out what specifications are necessary. Then you have the game engine. That's the compute state function that we just looked at with tic-tac-toe. So we can check to see is it a valid move, make the move, check for a win, is it a draw, all that stuff. And then state management, implement real-time state updates, add move history tracking. All of this stuff is unnecessary because we're using Jinaga. Jinaga does this. So I would prompt that right out of the plan. Then we do the components, have a nice user interface on top of that. Integrate those components, and it should be doing this by creating custom hooks. It's keeping it high level here. I would probably have it be a bit more specific. Although here's another tip for AI planning is if you get through like phase 3 and everything looks good, then go ahead and get started, and then come back and revise the plan with the AI. Now that you've learned a little bit more about how things are going, does that change the plan? Why, yes, it does. You're absolutely right. Let me change the plan. And you've got a much better plan proceeding forward from there. So that's the sort of thing that I would do here. And then we would get started with the implementation. We have a few more minutes, so let me kick that off. Let me do the first part of the plan. So I'll just close everything except for Connect for PRD, or not the PRD, the plan. We still want the PRD around, but we're loading the plan into context, and it can refer back to the PRD. I should include in my prompts, in my rules, that a plan should have a reference to the PRD. That way it knows specifically to look for it when it needs to. But all of the relevant information has been pulled forward, at least for this part. So let's proceed to this step right here with that step. Stop. Let's see, then update the checklist and stop when completed. So even though that's in the rules, only do one step at a time. I think that's in the rules. It should be in the rules. It really has a hard time stopping. So I always tell it, stop when you're completed with that. So it should be able to see the whole plan of, okay, this fact type, I want that to be in the Connect for TS. I mean, that's right there. So so here it created the Connect for TS. That's inside of GameHub model. Connect for TS, perfect. And it's proceeding with a whole bunch of extra static functions. So stop, you've already gotten off the rails. Implement only the Jinaga fact type. So, yeah, now it said, okay, I'm only talking about the Jinaga fact type. So, connect for game from game. I'm not sure what that one means. Connect for move in, connect for game. That one means something. Player index, move index. It's designing a more complicated fact than I would design. But that's why we do these things one at a time. This isn't nearly enough information for it to get everything right, even with all the rules about Jinaga and modeling. So it's our job to review this and make sure that this is actually going to work. Now, as I review it, I'm not going to push keep all on this one because I want to go in and modify things. But as I review it, we can see the extra steps that are necessary in order for you to integrate this model into Jinaga. So it knows this because it's part of the rules. So the Connect for model is built, including these two types, Connect for game, Connect for move. It forgot to do the predecessors. So I'll say declare predecessors in the Connect for model. And then, boom, there we go. Now we've got our predecessors. All right. And then it's fixing that import. Okay, now it's got the import. It put it all on one line. That's all right, I guess. But yeah, there we go. That's a decent looking model. So I would do things like get rid of row. Row is not part of the decision that the user made. The user made a decision of which column. The row, it's going to drop all the way to the bottom, as low as it can drop. So that's part of the game logic. That's part of the event sourcing that happens. So I would get rid of that. I would get rid of the player index. I would keep the move index, so you can now order these connect form moves by move index. So make the changes to the model, create a commit, keep going. That is how you can create your own game using Jinaga. So please, clone or fork the repo, clone it to your own machine, send me a note, say, yep, I have forked the repo, I am looking forward to creating a game. Then build it, run it in dev mode. Tell me, hey, I ran it in dev mode, I played a game of tic-tac-toe, it was cool. And then, proceed from there. Say, tell me what kind of game you want to write. I want to do Connect 4. I want to do Battleship. I want to do chess. I want to do Reversey. Reversey would be a good one. I like Reversey. Go or poker or whatever you want to implement. And then get started on updating your model. What does the model look like to support that game? Then use these AI tools to help you understand what is happening in the code, and to create plans for your game, to start to implement those plans. Then refine those plans, review those plans, see if those are going to be good Jinaga models, see if they are going to be good implementations of the game that you have in mind. So I can't wait to see what you build. Send me a note, and I will talk to you next week.